Question 6. In a liquid limit test using fall cone apparatus, the following readings were recorded. The first column is the sample number. So I have 4 samples, 1, 2, 3, 4. Water contents are 40%, 45%, 50%, and 58% for the samples respectively. And then the penetration of cone in millimeters equal to 12, 16, 21, and 35 respectively. While in plastic limit test, the following data were obtained. Weight of wet soil plus container, we have 22.12 grams. Weight of dry soil plus container, we have 20.42 grams. And then weight of container itself, by itself, it's 13.07 grams. First question, find the liquid limit, compute the plastic limit, and determine the plasticity index. Okay, paano ko ba siya i-discuss ng mabilis? Kapag, okay, I will show you a graph later on. Or maybe I can do this here. Meron tayong graph. In which yung horizontal is yung water content. And then yung vertical is yung volume. Tapos, i-graph natin habang tumataas yung water content, anong nangyayari sa volume. Usually, meron tayong ganitong graph. So, anong ibig sabihin nito? Habang tumataas yung water content mo, sa una, yung volume hindi nagbabago. Okay? Kasi nafe-fill lang niya yung voids pumunta lang siya sa void. So, yung volume mo, same. Pero habang tumataas yung water content mo at na-saturate mo na siya, tataas na rin yung volume mo. Diba? Kasi lahat ng voids, na-fill mo na ng water, wala nang ibang pupuntahan yung tubig. If that makes sense? So, aakyat siya ng aakyat. So, anong tinatanong sa graph? Ang tinatanong sa graph is liquid limit, plastic limit, and solid state. Let me put a graph here. This is very useful dahil magagamit natin siya. Hinati ko into 4 yung ating graph. I will send a clearer version of this one. Don't you worry, guys. For now, bear with me. Okay. Yung first area is the solid state. Solid state. I can't revise anymore. Solid state. Okay. Ito siya bago yung 0 yung yung 0 yung 0 yung slope. Yung solid state. And then kapag dumadami-dami na yung water content, meron ka ng semi-solid state. Semi-solid state. Ayan. And then, pag lumayo ka pa, let's put it here, and then one here. Okay, this one. Yung third area is the plastic state. Plastic state. And then, yung last is obviously yung liquid state. Okay? So this is the liquid state. Yung point dun sa graph, kung saan tumatawid ka ng state, ibig sabihin, this one, ito yung mga point of concern natin. So this one Ito yung solid state natin, so solid limit. Ilagay ko na rin siya. So dito, I have SL para dun sa unang point dun sa graph bago siya magkaroon ng slope. Itong midpoint, this is my plastic limit. And then yung point ko dito is my liquid limit. Okay? Ayan, I hope this is clear. Sana, somehow. Ano ang gusto nating makuha? Ano ang gusto nating makuha sa plastic limit test? Obviously, kailangan nating makuha itong mga ano na liquid limit, plastic limit, and then plasticity index. Para ma-define mo kung ano na ba, yung relation ng water content to volume. Ano yung effect niya doon sa soil sample. Okay? So, ang ginawa natin, meron kang soil sample. Okay, something like this. Sorry class, if you want this na screenshot, can you do it now? Kasi I need to remove pala. I need to delete. Kasi ano siya dun sa graph sa next na slide. Okay? I'll remove na, okay? Basta clear yan ha. Meron tayong 4 states, solid state, semi-solid, plastic state, liquid state. Okay? And then yung hinahanap natin is yung SL, PL, LL. Okay? I will clear it now. So, yung isang plastic limit test is ginagamitan ng penetration cone. Meron kang soil sample, tinataasan mo ng tinataasan yung moisture content niya, tapos mini-measure mo how deep you can penetrate the soil sample at each moisture content. Okay? So, ito yung graph niya. Meron kang penetration cone in millimeters, yung depth na na-penetrate dun sa horizontal axis, and sa vertical axis, you have the moisture content. So, idalhin ulit natin yung table nandun sa original problem. And then, magpa-plug ulit tayo. So, I have, let's start with the sample number 1. I have 40% na water content. So, this one, 40. And then, ang penetration ko is 12. So, I would say somewhere here siya dapat. Ayan. Alright? So, tuloy-tuloy lang siya hanggang sample 4. Sa sample number 2, 45%, 16 mm. So, somewhere here. And then 50% at 21 mm penetration. So, dito siguro. And then 58%, 35 mm penetration. 35, 58. So, somewhere here. Tapos 35 siguro dito. Ayan. Okay? And then, tulad nung ginawa natin dun sa, sa grain curvature, ipa-plot din natin siya. Connect lang. Alright? Ngayon, ang sabi sa formula sheet, anong sabi sa formula sheet? Ang sabi sa formula sheet, 22. Ayan. Yung liquid limit ko, dito tayo sa equation number 22 or item number 22. Yung liquid limit ko daw, yung water content corresponding to 25 blows or 20 mm penetration of cone. Okay? So, either number of blows ka or nandun ka sa penetration depth ng cone. Okay? So, balik tayo sa situation. Saan ako nanggaling? Is this 5? No, this is 6. Okay? Okay. So, ang sabi dito, ang sabi dun sa formula, kapag sa penetration cone, yung hahanapin mo, ano yung water content niya sa 20 mm na penetration. So, ganun ulit yung gagawin natin. From 20 mm penetration, maglalagay ako ng straight line, and then hanggang magkaroon ako ng intersection sa graph, kukunin ko yung moisture content at that specific area. Let's say 49. Okay? Let's say 49, kunyari. So, tulad ng sinabi ko sa inyo, hindi naman sila ganun kasadista siguro dun sa paglalagay ng choices. So, kapag hinanap yung moisture content, kunyari, magkakalayo naman yung ibibigay na value. Hindi naman siya 46%, 48. Kasi prone to error yung pag-graph lalo na pag naka-logarithmic scale ka. Okay. So anyhow, ipa-plug in natin. Sorry. Obviously, may dalawang option kayo. Either, kapag ganito, na almost linear na yung inyong graph, pwede ka na lang mag-interpolation. Okay? Kasi alam mo ito, let's say, alam mo itong point na ito, which is 45 versus 16. And then, meron kang second point, which is 50% to 21. So, kung gusto mong i-interpolate kung nasan yung 20, okay lang naman. Especially kung nakikita mo na ang behavior ng graph ay linear. Dito. Okay. Pero be careful pa rin kasi since logarithmic tong nasa ilalim, you can never tell. Pero I think kung na-eyeball estimate mo siya na ito yung value niya, tapos na-compute mo siya sa interpolation na magkalapit, shoot ka na. So, if I'm going to find the liquid limit, pero in terms of ratio and proportion or interpolation, I will have 20 minus 16 over 21 minus 16. Anong ginawa ko? Yung 20 minus 16 ko, yun yung penetration cone ko. So 20 mm minus 16 mm, this one. Tapos, ang denominator ko is 21 mm minus 16 mm. Kasi gusto kong makuha yung relationship nung moisture content. So, ang nandun sa right-hand side equation ay kung saan siya nagmamatch. Yung 20, yun yung unknown. So, yung 20, yung moisture content ko at 20, yun yung x. And I know yung moisture content ko at 16 ay 45. So, x minus 45. And then, yung denominator ko is yung nagmamatch na water content dun sa 21 minus 16. So, sa 21, meron akong 50%. Sa 16, meron ulit akong 45. So, the denominator will be 50.45. Okay? So, solving for x, ano dapat ang ating answer? Let me see. Tingnan natin. Makikishift solve nga po. I will do the same. X minus 45 over 50 minus 45. Class, again ha, let's try to make an effort na maghanap ng or mag-input ng trial value. 49, napakabilis ni Engineer Marlene. Yes, that is correct. So, ang ginawa ko lang, in-input ko lang siya. I don't know if you can see the screen. Like this. And then shift solve. And since alam ko na naglalaro lang yung moisture content sa 40 to 58 and dapat nasa gitna siya ng 45 to 50, let's say nag-assume ako ng 50 kasi yun yung mas malapit, and mabilis niyang ibinigay yung 49. Okay? 49%. So, Engineer Marlene, thank you. Engineer Roxanne, Engineer Mary Rose, thank you. You've all got the correct answer. I hope this is clear. Okay. Next. Ang next na hinahanap ay plastic limit. Plastic limit. Ang formula natin for plastic limit ay this one. Okay? Moisture kasi lahat naman ng limit na pinag-usapan natin, liquid limit, plastic limit, solid limit, or something like that, lahat ng yon ay moisture content. In moisture content siya. So, ang ibig sabihin, yung plastic limit ko ay in terms of moisture content din. And yung formula natin for moisture content is weight ng water over weight ng soil. And yung weight ng water, makukuha ko siya sa weight ng moist soil sample minus weight ng dry. Okay? W sub M minus W sub D. And then, yung weight ng soil ko is just W dry. Weight ng dry. In this case, given na siya. Kasi yung lahat ng information na kailangan mo given na doon sa problem. Kasi plastic limit test niya siya, di ba? So, yung mga information na makukuha mo dito, especially yung moisture content, is in connection to the plastic limit. So, para makuha ko yung weight ng moist water, weight ng moist soil sample, I will use 22.12 grams and then ilales ko yung container. Kasi weight of wet soil pa siya, tsaka container eh. So, it will be 22.12 minus 13.07. Okay? I hope that is clear. Tapos, pagdating naman sa dry, I'll do the same thing, but this time, ang gagamitin ko ay yung 20.42. I have a typo. I'm sorry. This should have been 42. So, 20.42 minus 13.07. And of course, yung denominator ko is just the same. 20.42 minus 13.07. Okay? Solving for plastic limit, we have, napakabilis ni Engineer Rancy. It's correct, and you are correct. 23.13%. Okay? Okay, last unknown before we take a quick break. The last unknown is determine the plasticity index or P sub I. In this case, yung P sub I, ang formula number, I think 27, this one. Okay. Plasticity index, liquid limit minus plastic limit. So, it's very, plug and play. Kasi we already know the liquid limit, 49, and then the plastic limit is 23.13. What is my plasticity index? Correct. Engineer Renzi is correct. It's 26 or 25.87%. And also Engineer Roxanne. Ayan, okay. So, first, ang gagawin natin para makuha natin yung, what you call this? Yung liquid limit, ay magpe-prepare tayo ng, my screen is acting up. Okay, magpe-prepare tayo ng soil sample. Lalagay natin siya sa cylinder na to. Na-print screen ko pa yung cursor. I'm sorry. So, ilalagay natin siya dun sa container. And then, mayroon tayong tinatawag na cone penetrometer. So, ang mangyayari sa kanya, this is a section ha. This is a section view of the cone penetrometer. Ang mangyayari sa kanya, meron kang cone, eto, parang nandun sa may shaft. And then, itong cylinder natin na 50 by 50, ilalagay natin dito sa ilalim. So, ang magiging setup niya is something like this. Okay, so meron kang penetrometer, tapos itong may cone, ito yung mahuhulog via free fall. Okay? So, pag ang sinasabi natin ay gusto natin para sa what you call this, kailangan natin ng 20 mm penetration, this one, yung given dun sa, yung required dun sa first unknown. Ang ibig sabihin lang niya, yung 20 mm penetration, dapat yun yung distance na to. Okay? So, yung cone mo, na dinrop mo siya via free fall, tapos penetrate niya yung soil sample mo, dapat 20 mm siya. Of course, hindi naman siya isang try lang, 20 mm na siya agad. It's not like that. So, ang ginagawa natin, nagta-trial and error ka, using different moisture contents, tapos titingnan mo kung halimbawa may moisture content ka na, tulad dun sa example natin kanina, yung sample mo may water content na 40%, tapos dinrop mo yung penetration cone, meron kang 12 mm. So, ililista mo yon. And then so on and so forth. Dapat yung penetration mo, yung penetration cone mo, mag-vary from less than 20 to more than 20 para pumasok doon yung hinahanap natin na value na 20 mm. Okay? So, halimbawa, pinataas mo na yung water content para doon sa soil sample. Yun naman na 58%. Tapos, syempre, kung mas mataas yung water content mo, mas lulubog yung cone, di ba? Kahit na free fall siya. So, pag nilet go mo yung cone, sa nakikita natin, 35 mm yung na-penetrate niya dun sa soil sample. So, kaya tayo nakapag-graph ng something like this. Ayan. Something like this. And then, since wala dun sa sample natin yung exactly 20 mm penetration, nag-try tayong what you call this? Mag-interpolate or by calculation or by eye estimate. Okay? I hope that is clear para sa fall cone apparatus, which is the penetrometer. Next, ang i-discuss naman natin ay number of blows naman. Mayroon tayong tinatawag na Casa Grande cup. Ito yung, I think ginamit natin 'to nung undergrad days, 'no? Medyo matagal-tagal na panahon na. Pero basically, ang mangyayari sa kanya, yung cup mo, lalagyan mo siya ng soil sample like this, okay? And then, magke-create ka ng gap. May scraper diyan, ito yung red. Magke-create ka ng gap sa gitna dun sa soil mo na obviously may moisture content, 'di ba? And then, ang goal natin is, i in Tagalog term, paano ba, itagtag or ah, hindi naman siya ihampas-hampas, eh. Parang dapat lagi siyang, I'm losing my words. Parang iuuntog mo siya dito sa flat surface dito hanggang magkaroon ka ng closed, meron kang half an inch na yun yung tinatawag natin na number of blows. Siyempre tulad nung, what you call this, yung sa cone test, hindi mo rin sure kung sasakto ba sa 25 numbers ng blows na magko-close yung iyong, soil sample, 'di ba? So, gano'n din yung gagawin natin dito sa next na problem. So, yung sa situation 7 naman, imbis na yung penetration, distance, or depth, yung kinukuha natin, ang ibinigay naman dun sa test ay yung number of blows at saka yung corresponding water content na nag-close yung gap ng half an inch. Okay? So, for example, sa sample A, ang water content natin ay 41.8%. Para mag-close yung gap na ito, para mag-close yung gap na 'to, kinailangan niya ng 39 number of blows. Okay? Siyempre habang tumataas ulit yung water content mo, mas, nagiging flowy yung soil sample. So nung tinaasan naging 45.5% yung water content, konting blows na lang yung kailangan para close yung gap. Okay? Hindi natin nire-reuse yung same setup nito, na parang, okay, 39 blows tapos nag-close ta's pipipiin mo na lang siya para magamit mo ulit dun sa susunod. Hindi. Kasi yung susunod mo na blow dapat na na-check mo na for a different water content. 'Pag natapos na siya sa 39 blows corresponding to 41.8, kukuha ka ulit ng sample, adjust mo yung water content. In this case, yung sample B natin may 43.5 and then repeat the same procedure. Okay? So, ang tinatanong is, in a liquid limit test using cup apparatus, the following data were taken. We have 4 samples, A, B, C, D. Let me just, I don't know if you can hear my notification, so let me just turn it off. Mute. I don't know how. Okay. All right. So, water content for samples A, B, C, D, we have 41.8%, 43.5%, 44.3%, and 45.5%. And like what we've mentioned a while ago, the higher your water content, the lesser the number of blows that it will require para ma-close mo yung gap dun sa test. Okay? So for sample A, 39% lang. 39 number of blows yung kailangan mo. Kasi more on the dry side siya. 41.8% lang yung moisture content mo eh. For sample B, we have 23. For C and D, we have 20 and 13 respectively. And while in a plastic limit test, the following data were observed. Weight of wet soil plus container, we have 21.19 grams. And then the weight of dry solid plus container, we have 18.78 grams. And lastly, we have weight of container, we have 8.20 grams. Okay? Yun pa rin ang hinahanap, find the liquid limit compute the plastic limit, and then solve for the liquidity index if natural water content is 38%. May bago na namang unknown. Pero for now, we're going to plug in the values like this. Okay, so kanina, ang naandun sa horizontal axis natin is depth of penetration. Ngayon, number of blows na siya. I-transport ulit natin yung table here. So we have the table na same na nandun, same sa given. Okay? So ipa-plug in lang ulit natin. Let's say sample A, I have water content equal to 41.8%. So somewhere here. And then yung number of blows daw ay 39. So I would say andito siya. Malapit sa 40. So here. And then I have 43.5%. So dito, lower half ng 40 to 45. No. So upper, siguro. And then 23%, it will be somewhere here. And then C, I have 44.3. Okay. And then 20. So dito, malapit sa 45. Okay. And then lastly, I have 45.5. So lumampas na ako sa line na to. And then 13 number of blows. So siguro, where? Around here. Ayan. Then same sa ginawa natin. Ayan. I-dikit-dikit lang siya or trace mo lang yung notes and then that will be your graph for number of blows versus moisture content. And ang sabi dun sa ating formula sheet, kapag number of blows na yung hinahanap, ang kukunin na natin ay yung 25 number of blows na nagsara siya. So, from the horizontal axis, kunin natin yung 25 and then project upwards. So, mas malapit siya dun sa 30 kasi logarithmic scale. And then, hanggang ma-intersect niya yung graph. And then, project lang to the left. So, in this case, ang assumption natin is 43 siya. Yung ating moisture content. Okay? So, babalik tayo sa ibang unknown. Ang hinahanap ay liquid limit. So, ang sabi natin, yung liquid limit is the water content at 25 numbers of blows. Chinek natin siya by eye estimate, eyeball lang. Ang sabi natin 43. I-check natin siya in this time, ano naman siya? What you call this? Interpolation. Okay. So, I have 39 minus 25. So, ang ginamit ko, obviously, is sample A. Okay? Ang ginamit ko is sample A. Mayroon akong 39 number of blows minus 25 kasi yun yung gusto kong point of reference. And then, ang denominator ko is 39 minus 23. Okay? So, yung 39 number of blows ulit siya over number of, less number of blows naman ng sample B, which is 23. Then, like yung ginawa natin kanina, kung ano yung corresponding water content mo per number of blows dito na nasa left, yun din yung ilalagay mo sa right. So at 39, I know that my water content is equal to 41.8%. And then 25, for number of blows, wala siya dito, pero yun yung kailangan natin. So I will put that as X. And then sa denominator, I have for 39, still 41.8. And then for 23 number of blows, ang water content ko ay 43.5%. So that will be my denominator. Okay? So, that's such a mouthful. So, solving for X, which is the water content at 25 number of blows. Can you please calculate? While I'm refilling my water. Come on, shift solve lang. Shift solve lang yan, class. And of course, since ang kinuha natin is within 39 and 23, dapat yung moisture content natin ay within 41 and 43, which is, ayan. Thank you, Engineer Roxanne, Engineer Ranji, and Engineer Agustin. The answer is 43% or 43.29. Okay? I hope that's clear. In-interpolate lang natin para mabilis. And i-reiterate ko ulit sa mga late nakarating, don't worry kung yung I will estimate if you would prefer to do it like this, ay medyo mahirap kasi nakadepende ka sa graphing. It's okay. They are quite friendly with regards to sharing, I mean, giving options or giving the choices. Okay? Next unknown. Number 2, compute the plastic limit. Hindi ako nakapagbigay ng photo dito. Okay, for plastic limit, ang test naman sa kanya is in terms of rolling. Ganyan. Na kukuha ka ng soil sample, again, iba-iba siya ng moisture content. Pero, ang gusto mo, pag 3 mm na yung diameter nung what you call this, soil coil mo, dapat magbe-break na siya in itself. Kapag maaga siyang nag-break, ibig sabihin, hindi mo pa naabot yung plastic limit. Okay, siguro, okay, magsisend ako ng photo maybe later para makita niyo yung itsura. Basta, meron kang soil sample and then i-roll mo lang siya hanggang makarating ka dun sa 3 mm na dapat 3 mm pa lang siya magbe-break. Okay? 3 mm yung diameter. So, maliit siya. But if we're going to compute for the plastic limit, again, we already have the information that is needed to answer this one. We will just reuse the formula na ginamit natin dun sa situation 6. So we have moisture content is equal to weight of water over weight of soil. Yung weight of water is, again, equals to the weight of moist soil sample minus weight of dry sample. And then yung denominator natin is weight of dry. Okay. So plugging in, we have yung weight ng moist sample natin is 21.19 as per yung given. Weight of wet soil plus container. Pero since may container pa siya, ilaless natin yung 8.2 grams. So that would be 21.19 less 8.2. And then, yung weight ng dry natin, it's just 18.78. Excuse me. Less pa rin ng container. So it's like this. And all over, yung weight ng dry, which is still 18.78 minus 8.20. Solving for the plastic limit, we have, napakabilis ni Engineer Ranji. Pero parang, am I wrong? Wait lang, Engineer. I think baka mali yung aking calculation. 10.78 minus 8.2. Again, 21.19 minus 8.2 minus 18.78 minus 8.2 over 18.78 minus 8.2. Okay, mali ang aking PowerPoint. I've written here 20.47%. Pero you are correct, guys. Even Bernadette participated. Oh my gosh. I love you, Bernadette. And Engineer Agustin, and Engineer Arnold, Engineer Mary Rose, everyone, Engineer Roman, you all got the correct answer. Engineer Roxanne and Engineer Renzi.
Love you too, Engineer.
It's 22.78%. Okay? I will correct this specific sheet. So, wag niyo muna siyang, before niyo i-screenshot. Last unknown for this set. What is or solve for the liquidity index of natural water if natural water content is 38%. Let us check the formula sheet kung anong pwede natin gamitin. In this case, anong pwede natin gamitin? Formula number 28, tama ba? Yes. Okay. Liquidity index. So Li is equal to moisture content or water content minus plastic limit over liquid limit minus plastic limit. And then you will have the rating here. If your liquidity index is less than 0, of course, it's brittle solid. kulang yung moisture content mo, masyado siyang brittle. Kung yung liquidity index mo is between 0 to 1, it is plastic. If it's more than 1, it is liquid. Patubig na, ibig sabihin. Okay? Ba, napakabilis naman ni Engineer Roman magsagot. Pero, let's try it among ourselves. We have Li is equal to moisture content minus plastic limit over liquid limit minus plastic limit. So, moisture content, alam na natin, it's 38. And then, yung plastic limit is 22.82. Okay, so tama pala talaga. Nag-typo lang ako dito. And then, liquid limit natin is 43.29 minus 22.82. Solving for liquidity index, Engineer Roman is correct. So we have 74.16%. Let me just, before you screenshot this, class, let me just revise this really quickly. Baka antok na ako kagabi. I'm sorry. Okay.